Hello students, we shall start with the chapter Speed, Time and Distance. The concepts of time and speed are very important from exam perspective. In the following section, we shall learn about the formula, the concepts and various scenarios like the train problems and the relative speed, conversions, etc. So let's begin. In this lecture, we are going to cover the conversions, learn about distance and speed relation, about train problems, and lastly about the concept of relative speed. So let's begin with conversions. Now, while solving any problem on the concept of speed, the relative units have to be uniform. In other words, the units throughout any calculation shall be the same. The most common units are the meter and kilometer. Let's understand some conversions. That is, suppose you have to do a distance conversion. We know that 1 meter is equivalent to what? 1.0936 yards. Or I can say that this is equal to 39.370 inches. Also we have what? We have 1 upon 100 meters equals to what? 1 centimeter. And 1 upon 1000 meters is nothing but what? 1 millimeter. Now we can easily make the conversions from one system of unit. For example, like if a man covers 30 feet in 10 seconds, then what is his speed? Suppose, let's say in meters per second. So we know that 1 meter is equal to 3.28 feet. So 1 meter is equal to what? 3.28 feet. So we can write that 30 feet equals to what? 1 upon 3.28 into 30. Correct? And this is going to be what? This is going to be 9.146 meters. So the speed of the man is going to be what? 9.146 upon 10 meter per second, or I can say it's going to be 0.9146 meters per second. Therefore, the correct answer is going to be what? 0.9146 meters per second. Alright. So let's move forward and learn about some time conversions. Now the time conversions are simple. We know that each minute has what? 60 seconds and each hour has what? 60 minutes. Therefore the number of seconds in 1 hour is going to be what? 60 into 60, that is 3600 seconds. Alright. So what I meant is that the number of seconds in 1 hour is going to be what? 60 into 60. That is 3600 seconds. Alright. Now, there is this trick for speed conversion. Now, let us use both the tricks to do the most common conversion that you will encounter in this section. The most common conversion is from kilometers per hour to what? Meters per second. So, let's see what we can do here. That is, convert 1 kilometer per hour to what? Meter per second. So what we need to do is, we know that 1 kilometer is nothing but it is equal to what? 1000 meters, correct? Also we have seen that 1 hour is nothing but 3600 seconds. So can I write that 1 kilometer upon 1 hour, or I can say 1 kilometer upon hour is nothing but 1000 upon 3600 meters per second. That is nothing but 5 upon 18 meters per second. Correct? Correct. So it's 5 upon 18 meters per second. For example, a body is moving, let's say, at a velocity of 60 kilometers per hour. So let me just erase it so that we can solve it. So, alright, you need to write the question, and the question is what? Alright. So the question is what? The question is that a body is moving at a velocity, and the velocity is what? Velocity is 60 kilometers per hour. Alright. Now its speed in meters per second we need to find out. So if you want to change any speed from kilometer upon hour to what meters per second, you need to multiply kilometer upon hour by the factor of what? 5 by 18, which we just saw. So in this case, we can write what? We can write that 60 into 5 upon 18 is going to be what? 16.67 meters per second. So this is going to be what? This is going to be our answer. Let's move forward on the topic distance and speed relation. Now in distance speed relations, we will learn about the distance formula. We will also see the velocity formula. So let's first understand what is distance, speed, displacement and velocity. Now the distance is the actual length of the path that the object will travel. And the displacement is the shortest distance between the initial position and the final position of the journey. For example, if an object goes in a circle, suppose an object is going in a circle and from this point it returns to its original position, alright, then its displacement is going to be 0 while its distance is not. In general, we say that distance is either greater than or equal to your displacement of any object. The displacement can never be smaller than the distance. The velocity is the time rate of change of displacement. Suppose if Fs is say the displacement of the object in some time, that is capital T, then the velocity is equal to what? V equals to S by T. Alright, so V is nothing but V equals to S upon T. The units of velocity are what? Meters per second or kilometer by hour. Now the speed is the time rate of change of distance. If d is suppose the distance of the object in time t, then speed will be equal to what? Speed is going to be distance upon time. It has the same units as velocity. Let's solve some examples and we will introduce the formula as we go along. So the first question states what? The first question states that the speed of a bus is what? 54 kilometers per hour. If we don't let it stop at any point, if the bus stops at the bus stops, the speed of the bus is what? 45 kilometers per hour. So what is the time that the bus stops per hour? Now the relation between distance, speed and time is what? We know that speed is nothing but speed is distance upon time. Therefore we have what? We have that distance is nothing but distance is speed into time. So distance is nothing but it is speed into time. As the speed of the bus is what? 54 kilometers per hour, it will cover 54 kilometers in 1 hour. Similarly, when we let the bus stop, it will cover what? 45 kilometers per hour. Therefore, due to stoppages, it covers 9 kilometers less. So, time taken to cover 9 kilometers is going to be what? Distance upon speed. That is nothing but 9 upon 54 hours, which is going to be nothing but 9 upon 54 into 60 minutes. So this is going to be what? 10. So answer is going to be what? Option number B, that is 10 minutes. Let's solve one more question, and the question states that a certain motor car starts at a speed of what? 70 kilometers per hour. And it accelerates, increasing its speed every 2 hours by the amount of what? 10 kilometers per hour. So what is the time it will take to cover a distance of what? 345 kilometers. What you people can do is, if you understood how we need to solve these types of questions, you can pause the video and attempt this question on your own. Otherwise, let's solve it. So we know that the distance that the car covers in the first 2 hours is what? 70 into 2 kilometers. Correct? That is nothing but 140 kilometers. So it is nothing but it is 140 kilometers. Also, the distance that the car covers in the next 2 hours is going to be what? 80 into 2, that is nothing but 160 kilometers. Correct? Thus, the remaining distance is what? 345 minus 140 plus 160. That is going to be nothing but 45 kilometers. Therefore, the speed in the 5th hour is going to be what? 90 kilometers per hour. Correct? So, it's going to be 90 kilometers per hour. Also, the time the car takes to cover 45 kilometers is going to be what? 45 upon 90 hours. Okay? So, it is going to be nothing but half hour. half hour. Therefore, the total time taken is going to be what? The total time taken is going to be 2 plus half. That is 4.5 hours. So, the correct option is going to be option number A, that is 4.5 hours. Let's move forward, and there is this one more question. Just see, it's a previous year question of the year 2006. Now, Arun Barun and Kiran Mala starts from the same place and travel in the same direction at the speeds of what? 30 kilometers per hour, 40 kilometers per hour and 60 kilometers per hour respectively. And Barun starts 2 hours later than Arun. If Barun and Kiran Mala overtake Arun at the same instance, how many hours after Arun did Kiran Mala start? Now let A, B and K represents the speed of Arun, Barun and Kiran Mala. Okay. So it's going to be what? It's going to be A, B and K. Now here the distance, this is going to represent the speed of what? Arun, Barun and Kiran Mala. So the distance constant, I could say that A by B equals to what? B by A, that is, these are the speed and then the small ones are the distances, and this A, B by A, and this will be equal to what? B by A, that is nothing but 3 by 4, that is gap of 1, but we need gap of 2, okay. So this is 3 by 4 and we need gap of 2 as Barun started 2 hours late. So B is going to be what? 6 and A is going to be what? 8. So this is going to be the answer. Now for the second part of this question, I would say that A upon K is nothing but small k by A, that is 30 by 60, that is K by 8, that is K equals to 4 hours. So Kiran Mala started at what? 4 hours later. Let's move forward and understand what are train problems. Now, the train problems form an interesting portion of the time speed problems. Okay. Now, the train problem are a bit different than the regular problems on the motion of the objects. This is due to the finite size of a train. As a result of the length of the trains, many interesting train problems originate. Due to the small size of the cars and other objects, we take them as point objects. Since the size of the trains is comparable to the distances that they may travel, then we will have to take the size or the length of the trains into account too. The same formula that we saw already are applicable here too. Here we shall see some examples of this concept and then learn some more tricks and examples. So let's begin by solving some train problems. So the first question states what? The first question states that a train running at a speed of 60 kilometers per hour, it crosses a certain pole that is in the way 9 seconds away. Now what is the length of the train? Now the train crosses the pole in 9 seconds. This means that from the point when the engine or the front of the train crosses the pole to the point when the back of the train reaches the pole, we have what? Time equals to 9 seconds. So 9 seconds is that particular time. Thus we can get the length of the train by calculating the distance that the train travel in what? 9 seconds. Now we have the speed of the train, that is 60 kilometers per hour. We have to convert it into meters per second. So let's see the trick to convert kilometer per hour to what? Meters per second. So trick is simple. I just have to multiply it by 1000 upon 60 into 60. Correct? And this is going to be what? This is going to be 5 upon 18 meters per second. That is 1 kilometer per hour will be equal to this 5 upon 18 meters per second. Therefore, if the speed x, that is kilometer per hour, then we can change it into meters per second by multiplying x with what? 5 by 18. Let's do it for the current example. Correct? So we have the speed of the train as 60. So we can multiply it by 5 upon 18. That is, this will be equal to what? 50 upon 3 meters per second. 50 upon 3 meters per second. Therefore, in 9 seconds, the train will cover a distance of what? Speed into time. So, distance is going to be what? This speed into time is what? 9. That is 50 upon 3 into 9. And this is going to be what? 150 meters. So, the correct option is going to be what? The correct option is going to be 150 meters, that is option number B. Let's move on to the next question. The next question is a previous year question of the year 2002, and the question states that there is a tunnel connecting city A and B. Therefore, I'm so sorry, there is a cat which is standing at what? 3/8 the length of the tunnel from A. It listens a whistle of the train and starts running towards the entrance where the train and the cat meet. In another case, cat started running towards the exit and the train again met the cat at the exit. So what is the ratio of their speeds? Now let the speed of the train be x. So x is what? X is the speed of the train. When train runs x, then the cat runs what? 3. And when the cat runs 5, the train is going to run what? X plus 8. That is, what I am saying is that when the train is running x, the cat is going to run 3. And when the cat run 5, then train is going to run what? X plus 8. So equating, it will be what? It will be x is nothing but 12, and ratios of their speed is going to be what? 12:3. And when I'm going to solve, it's going to be what? 4:1. So the correct option is option number A, that is 4:1. Now let's move on to the next concept, and the next concept is of your relative speed. So the concept of relative speed is central to most physics. When do we say that a body is in motion? If you are lying perfectly still on the ground, are you in motion or are you at rest? Now the answer is that if you change your relative position with respect to something, you are in motion. Otherwise, you are in a state of rest. Now imagine that you have a dart gun with a muzzle velocity of what? 45 meters per hour. Further imagine that you are on a bus traveling along a straight highway at what? 55 mph. Okay. And that you point the gun so that the barrel is level and pointing directly forward towards the front of the bus. And assuming no recoil as it leaves the muzzle of the gun, how fast is the dart traveling relative to the road? So we need to find that out. Now 100 mph, the dart is already traveling forward at what? Forward at 55 mph. Relative to the road, just because it is on the bus that is moving at what? 55 mph, correct? Now we need to add the velocity of what? 44 mph that it requires as a result of firing of the gun, and you get the total velocity of the dart relative to the road, which is nothing but what? 100 mph. Or in other words, we can say that the velocity of one object is measured from another object is in relative speed and with respect to that particular object. There are broadly two cases in the relative speed. That is, number one, when the objects are moving in the same direction, and number two, when the objects are traveling in opposite direction. So let's move on to the first one. That is when the object is moving in the same direction. Now let's say that two objects with a velocity equal to A and B with respect to the ground are moving in the same direction. So they are moving in what? The same direction. Suppose you and your friend are both traveling in a train, or you are on a train and she is in a car, but both are traveling towards the same destination. That is what? In the same direction. Now let your velocity be A and that of your friend be B. Then the relative speed of your friend as seen by you will be equal to what? A minus B. Correct? This is known as what? This is known as your relative speed of A with respect to B, or in this case it will be what? Y minus X. Let's move forward and understand when both the objects are moving in what? Opposite direction. So let's say you are going from Bombay to Pune and your friend is traveling from Pune to Bombay in opposite directions. Then we can say that the relative speed is as what? A plus B, or in this case I would say that it is what? X plus Y, or the sum of the two velocities is, as I can state. Now the example can be what? Let me take one example. The example is that suppose a bus is traveling along a straight highway at what? A constant speed of what? 55 mph. So it is 55 mph. Okay. And a person sitting at rest on the bus fires a dart gun that has a muzzle velocity of 45 mph. And that too straight backwards. That is towards the back of the bus. Now we need to find the velocity of the dart relative to the road as it leaves the gun. So first of all, defining VBR to be the velocity of the bus relative to the road, that is VBR is going to be the velocity of your bus relative to your road, and VDR, that is the velocity of your dart that is relative to your road. And defining the forward direction to be positive direction, we have what? We have that VDR equals to VBR minus VDB. Or in other words, can I say that 55 mph minus 45 mph? Therefore, we may write that VDR is nothing but 10. So, VDR is going to be nothing but what? 10 mph in the direction in which the bus is traveling. Alright. So, let's solve an example and see whether we understood the concept or not. So, the question states that a certain train is what? 125 meters long, and it passes a man running at what? 5 kilometers per hour in the same direction in which the train is going. It takes the train 10 seconds to cross the man completely. Then what is the speed of the train? Now here we will have to use the concept of what? Relative speed. The relative speed of two objects is the sum of their individual speeds if they are moving opposite to each other. If the two objects are moving in the same direction, then their relative speed is equal to the difference between the two. Hence, if the man was at rest, or we can say that with respect to the man, it will be 125 by 10. That is, it is going to be what? It is going to be 125 upon 10 meters per second. Therefore, this speed of the train is going to be what? 25. I'm so sorry. So this speed is going to be what? This speed is going to be 25 by 2. That is 25 by 2 meters per second. Or in other words, can I say that it is 25 by 2 into 18 by 5 kilometers per hour? And this is going to be nothing but 45 kilometers per hour. Correct. Now let the speed of the train be x kilometer per hour. Alright. Then the relative speed of the train with respect to the man is what? X minus 5 kilometer per hour. Therefore, we must have what? X minus 5 equals to 45, or I can say that x is nothing but x is what? 50. Therefore, the correct option is going to be what? Option number C, because here it will be that x equals to 45 plus 5, that is nothing but 50. So let's move further and solve this question, and this question is of previous year and of year 1999. So let's solve this question and be done with the lecture. So the last question says that Navjeevan Express from Ahmedabad to Chennai leaves Ahmedabad at what? 6:30 am and travels at what? 50 kilometers per hour towards Baroda, situated 100 kilometers away. Now at 7 am, Howrah Ahmedabad Express leaves Baroda towards what? Ahmedabad and travels at 40 kilometers per hour. At 7:30, Mr. Shah, the traffic controller at Baroda, realizes that both the trains are running on the same track. How much time does he have to avert a head-on collision between the two trains? Now considering the reference time to be what? 7:30. So I'm considering that the reference time is what? 7:30 am. We would need to find the distance between the two trains at what? 7:30 am. Correct. Now from 6:30 to 7:30, the Navjeevan Express would have travelled 50 kilometers, and from around 7 to 6:30, from 7 to 7:30, the Howrah Ahmedabad would have travelled how much? 20 kilometers. Thus the distance separating the two trains at 7:30 will be what? 100 minus 50 minus 20. This is 50. I'm going to write 5 again. So this is 100 minus 50 minus 20. That is nothing but 30 kilometers. So 30 kilometers. And time to meet, that is the collision from 7:30 am is what? 30 upon the time, that is speed, that is 50 plus 40, and this is going to be what? 1/3 hours. That is 20 minutes. That is option number B. I hope you people have understood a little bit about speed, time and distance. We will resume with the next part in the next lecture. Till then, you can go to EduRev and attempt these tests to understand this chapter in depth. You can unlock all the logged videos, documents and tests with EduRev Infinity plan and ace your exam at less than 80 rupees per month. Thank you.